Imagine stepping outside on a sweltering summer day. The air shimmers with heat, the sun beats down relentlessly, and all you want is to retreat into the cool sanctuary of an air-conditioned room. That hum of the AC unit is our modern shield against nature's intensity, a convenience so ingrained in our lives we hardly think about it. But what if that hum suddenly fell silent? What if, like our ancestors, we had to face the blazing Mediterranean sun without any of the technology we take for granted? This isn't just a hypothetical question, it's the reality ancient Romans confronted every single summer. How did they not only survive but thrive in temperatures that would leave many of us desperate for relief? Without fans, without refrigerants, without anything powered by electricity, the citizens of Rome devised some of the most brilliant and elegant cooling solutions the world had ever seen. Their methods weren't just about enduring the heat, they were about mastering it. From revolutionary architecture to surprisingly sophisticated engineering, the Romans turned the challenge of staying cool into an art form. This is a story of creativity born from necessity, of intelligence applied to everyday life in ways that still leave us in awe. In this video, we're going to journey back in time to explore exactly how the Romans kept their cool. We'll walk through shaded colonnades, feel the chill of ancient aqueducts, and uncover secrets hidden in plain sight within the ruins of magnificent villas and public baths. You might be surprised to learn that some of their ideas are not just historical curiosities, they hold lessons and inspiration for us even today, in a world increasingly looking for sustainable ways to live comfortably. So come along as we step into the sandals of an ancient Roman and discover how genius flourishes when there's no easy way out. To understand how the Romans stayed cool, we first need to step inside their homes. The very foundation of their climate control wasn't an appliance, it was the architecture itself. Roman society was divided, and so was its housing, leading to two primary structures, each with ingenious, built-in answers to the heat: the luxurious single-family domus for the wealthy and the towering, multi-story insulae or apartment blocks for the common citizen. For a wealthy Roman family, their entire life unfolded within the walls of their domus. This wasn't just a house, it was a private oasis meticulously designed to provide solace from the noisy, bustling, and sweltering city streets outside. The layout was a masterclass in passive cooling, centered around a large, open-air courtyard known as the atrium. This central space wasn't merely for show, it functioned as the lungs of the home. Its open roof, called the compluvium, allowed the hot, stagnant air inside to rise and escape, while simultaneously drawing in cooler, fresher air from the surrounding rooms through a principle known as stack ventilation. But the atrium was just the beginning. The true heart of climate control in a domus was the peristylium, a colonnaded garden courtyard situated even deeper within the residence. This lush green space, often featuring a shallow pool or fountain, was the family's private retreat. The water from the fountain would evaporate, adding a noticeable chill to the air, while the shaded colonnades that surround it provided a cool, breezy walkway protected from the direct sun. The arrangement of rooms was also deliberate. Main living areas were strategically positioned to capture cross breezes, with fewer exterior windows to keep the heat out and the cool, internally circulated air in. Life for the masses, however, was dramatically different within the insulae. These brick and concrete buildings could soar to 6 or even 7 stories, housing shops on the ground floor and hundreds of people in small apartments above. You might think these cramped quarters would be unbearable in the summer, but Roman builders incorporated clever features here. 2 thick walls made of Roman concrete, a miraculous material we'll explore more later, provided immense thermal mass. They would absorb heat during the day and slowly release it during the cooler evenings, helping to stabilize the indoor temperature. Large shuttered windows were commonplace, not for views, but to be thrown open to catch any available breeze. While it was certainly more crowded and noisy than a quiet domus, the design of the insulae still represented a thoughtful, practical approach to making life livable for everyone in the relentless Mediterranean climate. This foundational understanding of airflow, shade, and water set the stage for the Romans' most brilliant and active cooling innovations. Now let's journey into the very center of the Roman domus to understand its most ingenious climate control feature. The atrium was far more than a grand entrance hall. It was the architectural command center for the home's entire atmosphere. This space operated on principles so effective they predate modern mechanical air conditioning by nearly 2 millennia. Its brilliance lay in a simple two-part design: the open roof, known as the compluvium, and the shallow rectangular pool directly beneath it, called the impluvium. The compluvium was a precisely engineered opening in the roof, strategically slanted to channel more than just sunlight into the home. During Rome's occasional but often heavy rain showers, this opening became a vital water collection system. Rainwater would cascade down the slanted roof tiles and pour through the compluvium, falling directly into the impluvium pool below. This pool wasn't just for decoration. It had a practical, porous base that allowed water to drain into an underground cistern, providing the household with a precious private water supply. But the system's true genius was revealed under the scorching summer sun. On a hot day, the shallow water in the impluvium would naturally begin to evaporate. This process of evaporation is a fundamental cooling mechanism, as it requires heat energy drawn directly from the surrounding air. The atrium, open to the sky, would become a natural chimney for hot air. As the sun heated the air inside the home, that warm air would rise and flow out through the compluvium. This created a powerful suction effect, actively pulling the cooler, moisture-rich air from around the impluvium throughout the surrounding rooms and hallways. It was a continuous, self-regulating cycle of ventilation and cooling, all powered by natural thermodynamics. The result was a constant, gentle breeze and a noticeable drop in temperature within the home's core. This cooler air would then circulate into the family's living quarters, displacing the stale, warm air. The atrium was a perfect marriage of form and function, providing light, fresh water and refreshing coolness, all while serving as the impressive centerpiece for receiving guests and conducting family business. It was the ancient world's most elegant and effective answer to the problem of indoor climate control. While the atrium acted as the home's natural air conditioner, the Romans knew that a truly comfortable living space required more than a single source of cool air. They possessed a sophisticated, almost intuitive grasp of aerodynamics, applying it not with complex machinery, but through the thoughtful orientation of a building itself. They became masters of harnessing the wind, turning entire structures into vessels designed to sail on cool summer breezes. The secret to this didn't lie in invention, but in meticulous observation and planning, long before the first stone was ever laid. A Roman architect or homeowner would carefully study the local environment, paying close attention to the direction of the prevailing winds, particularly the cool northwestern breeze known as the chorus. The entire layout of a domus was then strategically oriented to capitalize on this natural airflow. This was the art of cross-ventilation, a concept we still prize today. The goal was to create a clear and unobstructed path for wind to enter, travel through and exit the home, flushing out hot, stale air in the process. This system began with the main entrance door. Positioned to face the incoming prevailing wind, it acted as an intake valve, allowing a steady stream of fresh, cooler air to be ushered inside. But an inlet is useless without an outlet. Directly opposite this entrance and often in alignment with the central atrium, another doorway or a large, strategically placed window would serve as the exit. This created a wind tunnel effect, where air flowing in one side would be forced to accelerate as it moved through the home's interior, seeking the path of least resistance out the other side. This wasn't a gentle, random draft, it was an engineered current. The placement of interior rooms was crucial to this design. Corridors and hallways were arranged to serve as clear airways, while living spaces like dining rooms and studies were positioned directly within this flow to receive the full benefit. They even used interior doors as control mechanisms. Opening or closing them could fine-tune the breeze, directing it to specific areas or increasing its force. In multi-story insulae, this principle was just as vital. Apartments featured windows on opposite walls wherever possible, and the central open-air courtyards of these large buildings acted as giant ventilation shafts, drawing cool air up from the ground floor and pulling it through the entire structure. This intelligent design ensured that even in a crowded city, every Roman, from the senator in his villa to the baker in his apartment, could enjoy the simple, life-giving luxury of a cool breeze on a hot day. Yet the Roman genius for climate control extended far beyond the clever channeling of air. They understood that the very materials they built with could be engineered to work in harmony with the sun's rhythms. This brings us to one of their most passive and effective cooling strategies, the use of immense thermal mass. The secret weapon in this effort wasn't just stone or clay, but a revolutionary material that defined Roman construction, a substance called opus cementitium, or Roman concrete. This was no ordinary mixture. While we might think of modern concrete as a bland gray material, Roman concrete was a marvel of ancient engineering, formulated for both incredible strength and specific environmental performance. Its recipe was a carefully guarded combination of lime, volcanic ash, and aggregates like small stones or broken bricks. The volcanic ash, particularly from the region around Pozzuoli, was the magical ingredient. This ash, known as pozzolana, reacted with the lime and water to create a binder that was not only exceptionally durable, but also highly porous. This porosity is key to understanding its cooling properties. A thick wall built from opus cementitium and faced with brick acts like a giant thermal battery for a building. During the intense heat of the day, the sun's energy doesn't immediately penetrate the interior. Instead, the wall's dense mass soaks up that heat, absorbing it slowly and steadily. Walk inside a Roman building at noon and you'd immediately feel a noticeable difference from the outside air. The interior would feel significantly cooler and more stable. The walls were effectively shielding the inhabitants from the peak daytime temperatures. Then, as the sun set and the outside air began to cool, a fascinating reversal would occur. The heat stored within the walls would start to radiate slowly back out, not into the now cooler interior, but primarily outward into the night air. This process, known as nocturnal radiative cooling, effectively reset the wall's thermal battery. By morning, the structure would have purged much of its stored heat and was ready to begin the cycle all over again, absorbing the new day's warmth. This created a natural time lag, delaying the heat's transfer and ensuring the interior remained comfortable long after the outside world had become unbearable. It was a simple, brilliant, and zero-energy system that provided 24-hour climate moderation, making those thick Roman walls one of history's most effective and enduring forms of natural insulation. Walking across a Roman floor was an experience that engaged more than just the eyes. While we today might admire the breathtaking mythological scenes and intricate geometric patterns purely as art, every mosaic served a vital and refreshingly cool purpose underfoot. These floors, assembled from countless small pieces called tesserae, were typically made from local stone like marble or limestone, or from fired ceramic. Both materials share a crucial property: high thermal mass. Just like the thick walls of a domus, these mosaic floors acted as massive heat sinks. Throughout the cool night, the stone tiles would slowly release any stored warmth, settling to a low temperature. Then, as the sun climbed and the day heated up, the floor would begin its daily work, passively absorbing the ambient heat from the room air. This process created a wonderfully practical cooling effect. The stone remained noticeably cool to the touch, providing immediate relief to bare feet, a simple luxury in a hot climate, but the benefit was more than just a momentary sensation. By steadily drawing thermal energy out of the air, the mosaic floor actively helped to lower the overall temperature of the room itself. This was especially effective when combined with other architectural features. Imagine a breeze channeled through the open atrium and cooled by the evaporating water of the impluvium, now flowing across a vast, cool stone surface. The air would contact the chilled floor, drop in temperature, and then circulate throughout the living space, creating a continuous cycle of natural air conditioning. The choice of material was also no accident. Lighter colored stones, particularly white marble, were highly prized not just for their beauty, but for their reflective properties. A light-colored floor would reflect sunlight entering through windows or the compluvium, rather than absorbing it, which further helped to maintain a cooler interior environment. This combination of high thermal mass and high reflectivity made these stunning works of art one of the most effective and elegant tools in the Roman arsenal against the heat. They prove that for the Romans, beauty and function were never separate considerations. Every element of design, down to the smallest tile, was an opportunity to create a more comfortable and civilized world. Of course, the Romans understood that the most effective way to beat the heat was to stop it at the source, by blocking the sun itself. While their architecture masterfully managed the air and temperature inside, they also developed brilliant, large-scale solutions to create vast zones of cool, protective shadow outdoors. Their most famous innovation for this was the velarium, an enormous canvas awning system that could be deployed over the open-air seating of amphitheaters like the Colosseum. This was no simple patio umbrella, it was a masterpiece of maritime engineering repurposed for public comfort. Sailors from the Roman fleet, with their expert knowledge of ropes, pulleys, and canvas, were specially employed to operate this complex system. The velarium was a gigantic canopy made of linen or cotton sails, stretched across a network of ropes that radiated out from a central oculus, much like the support lines of a massive circus tent. Its purpose was incredibly sophisticated. It wasn't designed to create a sealed, dark environment, but rather to provide a delicate, dappled shade, a permeable barrier that filtered the sun's most intense rays while still allowing hot air to rise and escape. This prevented the arena from becoming a stifling, stagnant oven. For the tens of thousands of spectators packed into the stone bleachers, the velarium was the difference between a day of miserable, sun-scorched suffering and a comfortably shaded, and therefore enjoyable, spectacle. It transformed these colossal stone bowls from potential heat traps into climate-controlled venues, demonstrating a public commitment to citizen comfort on a truly grand scale. On a more domestic and enduring scale, the Romans perfected the art of the pergola. In the private gardens of a domus or gracing the courtyards of country villas, these structures provided a more permanent and beautiful form of shade. A Roman pergola was typically a framework of stone or wood columns supporting a latticed roof, but its genius was in what grew upon it. They would train climbing vines like grapevines, ivy, or wisteria to weave across the overhead lattice. Over time, these plants would create a dense living canopy of leaves and flowers. This living roof was far more effective than any static canvas. The foliage not only blocked the sunlight, but also actively cooled the air beneath it through a process called transpiration, where plants release water vapor. Sitting beneath the pergola meant enjoying a shade that was alive, fragrant, and actively humidifying the immediate microclimate. It was a cool green room without walls, an outdoor living space perfectly suited for leisurely dining, conversation, or quiet contemplation. This harmonious blend of architecture and horticulture created a serene and naturally air-conditioned retreat, proving that the most elegant solutions often work in partnership with nature itself. Beyond the clever manipulation of air and stone, the Romans engaged another powerful elemental force in their quest for comfort: water. It was never merely a utility for them. It was a living, dynamic element of decor and climate control, integrated into the very fabric of their daily life. In any respectable Roman home or public space, the gentle, cooling presence of water was an absolute essential, achieved through an array of fountains, pools, and elaborate monuments known as nymphaea. The most common feature was the simple fountain, a fixture in even modest courtyards. The technology behind it was elegantly straightforward, relying on the constant pressure provided by the city's vast network of aqueducts. This ensured a steady, gravity-fed supply that could be piped directly into a home, where it would jet into a small basin before being drained away or recirculated. The effect of this moving water was twofold, offering both a tangible physical benefit and a profound psychological one. Physically, the process of evaporation is an endothermic reaction. It requires heat energy to occur. As water molecules broke free from the fountain spray and entered the air, they drew that necessary heat from the immediate surroundings, creating a perceptible pocket of cooler, moister air right around the feature. This wasn't a massive temperature drop, but in the dry Mediterranean heat, even a slight increase in humidity and a minor cooling effect could make an outdoor space feel refreshingly comfortable. Psychologically, the impact was perhaps even greater. The sight of sparkling, clear water and, most importantly, the sound of its quiet splashing or trickling has a deeply calming effect on the human mind. In a bustling, crowded, and often chaotic ancient city, the murmur of a private fountain created an auditory oasis, a barrier against the noise of the streets that promoted a sense of peace and tranquility. This feeling of calm itself can make a person feel subjectively cooler, reducing the stress and agitation that often accompany intense heat. A Roman could recline on a bench near their courtyard fountain, feeling the faint mist on their skin, listening to the gentle water music, and be transported away from the sweltering reality just beyond their walls. For those with more space and wealth, this concept was expanded into decorative pools or piscinae. These were not for swimming, but rather for ornamentation and reflection, both literal and metaphorical. A still pool of water acted as a brilliant thermal mass, much like the mosaic floors, remaining cool throughout the day and helping to lower the ambient temperature of the garden. Its mirror-like surface also reflected light, making a shaded colonnade feel brighter and more open, enhancing the overall sense of space and serenity. The most extravagant expression of this aquatic artistry was the nymphaeum. These were monumental public fountains, often taking the form of an elaborate semicircular facade decorated with statues of nymphs, gods, and mythological figures, all set within a grand apse of colored marble. Water cascaded from multiple spouts and channels over intricate rockwork into a large basin below. A nymphaeum was far more than a civic water source. It was a breathtaking piece of environmental theater. It served as a public cooling station where citizens could gather to collect water, socialize, and simply enjoy the spectacular display. The sheer volume of water and the complex interplay of its sounds, from roaring cascades to delicate dribbles, created a massive zone of cool, humidified air, a welcome refuge from the sun-baked forum. These structures celebrated the life-giving power of water, transforming the practical act of staying cool into a communal and almost sacred experience, showcasing Roman ingenuity at its most magnificent and public-facing. But perhaps the most secretive and ingenious cooling space in the Roman world wasn't a sun-drenched courtyard or a breezy hallway. It was a place hidden in shadow beneath the very feet of its inhabitants. Welcome to the Cryptoporticus, a marvel of subterranean engineering whose name literally means hidden portico. This was a long, semi-subterranean gallery, partially buried underground with its roof either at or just above ground level. From the outside, it might have looked like a simple, windowless foundation or terrace wall, but on the inside, it served as one of the most effective and consistent natural refrigeration systems ever devised. The principle behind its cooling power was brilliantly simple: geothermal mass. While the air temperature above ground could swing wildly from a scorching afternoon to a chilly night, the temperature of the earth just a few feet below the surface remains remarkably stable and cool year-round. The Cryptoporticus was designed to tap directly into this natural constant. Its thick earth-bermed walls and often vaulted ceilings, constructed from that miraculous Roman concrete, acted as a massive conductor for the earth's coolness. The space itself, being entirely enclosed and having very few, if any, external openings, was completely insulated from the fluctuating heat of the outside air. This created an environment of profound and steady coolness, making it perfect for two critical functions. Its primary use was as a high-end Roman pantry or cold cellar. Here a wealthy family could store their most perishable goods: amphorae of wine and olive oil, baskets of fruits, vegetables, and cheeses. The stable, cool, and dark conditions drastically slowed down the process of spoilage, functioning like a pre-modern walk-in refrigerator. This allowed for a more varied and luxurious diet regardless of the season. But the Cryptoporticus was more than just a storage room. It was also a seasonal living space, a cool retreat or promenade for the hottest hours of the day. When the sun made the beautiful open-air peristyle garden unbearable, the family could descend into the shaded, quiet embrace of the Cryptoporticus. Here they could stroll, converse, or simply relax in an atmosphere that was naturally 10 to 15 degrees cooler than the world above, all without a single moving part or energy source beyond the enduring chill of the earth itself. It was the ultimate hidden luxury, a secret garden of coolness buried in the very foundations of their home. But the mastery of their environment didn't stop at the walls of the house. It extended gracefully into the open air of the private garden or hortus. More than just a decorative space for relaxation, this area was a meticulously designed ecosystem that functioned as the home's natural air conditioner and refrigerator. The true pinnacle of this concept was found in the peristylium, the colonnaded garden courtyard that served as the verdant, beating heart of the Roman domus. This was not a wild, untamed plot of land, but a carefully curated landscape where every plant, path, and water feature was chosen for its role in creating a cooler, more breathable microclimate. The primary cooling mechanism here was once again the profound power of shade. The colonnade itself, a covered walkway supported by a continuous line of columns, provided a wide protective ring of shadow around the entire garden perimeter. This allowed the family to stroll, dine, or converse outdoors while remaining completely shielded from the direct, punishing rays of the sun. But the Romans took this a crucial step further by transforming the open central space into a lush canopy. They planted a variety of deciduous trees, such as plane trees, elms, and fruit-bearing figs or olives whose broad leafy branches would spread out high above, creating a second, living layer of dappled shade over the entire courtyard. This double-roofed effect, one made of stone and one made of leaves, drastically reduced the solar radiation that could heat the ground and the air within the enclosure. Beneath these trees, the garden was often filled with lower shrubby plants and fragrant herbs like rosemary, lavender, and mint. These plants contributed to the cooling process through transpiration, releasing moisture vapor into the air from their leaves. This gentle, constant humidification provided a noticeable and pleasant cooling effect, much like the way our own bodies cool down through perspiration. The result was a space that could feel refreshingly several degrees cooler than the sun-baked streets just beyond the property walls. The air itself felt different, fresher, cleaner, and scented with the perfume of flowers and herbs, which also helped to mask the less pleasant odors of the ancient city. This combination of deep shade and botanical humidity made the peristyle garden a genuine refuge, a natural sanctuary where one could physically feel the temperature drop upon entering. And at the center of this green oasis, you would almost always find water, a small burbling fountain, a reflecting pool, or even a narrow channel known as a Euripus, modeled after the canals of Alexandria, would complete the scene. The sound of moving water added to the serene atmosphere, while the process of evaporation from its surface provided an additional active cooling boost, working in perfect harmony with the transpiration from the plants. This courtyard was far more than a pretty backyard. It was the home's cooling lung. It inhaled the hot, stale air, and through the combined magic of shade, plants, and water, it exhaled a continuous supply of cooled, refreshed, and oxygenated air that would then circulate through the surrounding rooms, perpetually revitalizing the entire home. And while the architecture created a cool environment, the Romans also made a conscious and intelligent choice in what they wore, understanding that personal comfort began with the very fabric against their skin. Their approach to fashion was fundamentally practical, prioritizing comfort and climate control in a way that modern performance wear is only now rediscovering. The standard garment for a Roman citizen, regardless of gender or social status, was a simple, loose-fitting tunic. This was not a tight, restrictive piece of clothing. It was essentially a large rectangle of fabric, folded and draped over the body, fastened at the shoulders with pins or brooches, and tied with a belt at the waist. This design was revolutionary in its simplicity, creating a billowy, tent-like shape that allowed air to circulate freely around the body. The choice of material was even more critical than the cut. While wool was common and valued for its warmth in winter, the summer wardrobe was dominated by linen, a textile celebrated for its exceptional breathability. Linen is made from the fibers of the flax plant, and its structure is naturally hollow. This unique quality allows it to act like a tiny straw, wicking moisture, in this case sweat, away from the skin remarkably quickly and facilitating rapid evaporation. This evaporative process pulls heat away from the body, creating a genuine cooling sensation. A Roman in a linen tunic would stay drier and feel significantly cooler than someone in a less breathable fabric, even while performing strenuous activity under the hot sun. For the elite, the ultimate luxury was silk, imported at great expense along trade routes from China. Silk was prized not just for its sheen and softness, but for its incredible lightness and temperature-regulating properties. It is a natural protein fiber that is both absorbent and a poor conductor of heat, meaning it felt cool to the touch and did not trap body heat against the skin. A wealthy Roman woman might wear a delicate silk stola, a long draped dress over her linen tunic, creating layered yet still airy and ventilated clothing. Even their footwear was designed for ventilation. Many sandals were crafted with open straps and a lattice design, preventing feet from becoming hot and sweaty. This thoughtful approach to personal attire completed the Roman strategy for beating the heat. They didn't just create cool buildings to retreat into, they wore portable, personal climate control systems. Their clothing worked in perfect harmony with their architecture, allowing them to move comfortably through their day, from the shaded colonnades of their homes to the sun-drenched public squares, always dressed for the weather in the most technologically advanced and comfortable fabrics of the ancient world. And after adjusting their attire for the climate, a Roman seeking the ultimate relief from the heat had one quintessential destination: the public baths. While we might think of these complexes today as mere centers for hygiene, they were in fact the ancient world's most sophisticated and social spa resorts, with climate control at the very core of their design. The bathing ritual followed a precise sequence of rooms: the caldarium hot bath, tepidarium warm room, and finally, the magnificent frigidarium. This last room was far more than a functional endpoint to the process. It was the grand cooling climax of the entire experience, a place where the body was not just cleaned, but physically and delightfully shocked back into a state of perfect, refreshing equilibrium. Stepping from the humid warmth of the tepidarium into the frigidarium was a profound sensory experience. This vast hall was architecturally designed to stun the senses with its grandeur and its chill. Soaring vaulted ceilings, often adorned with intricate mosaics depicting sea gods and oceanic scenes, created a sense of expansive, cool openness. The walls and floors were sheathed in the most expensive, brilliantly white marble, not merely for opulence but for its superb ability to reflect light and feel cool to the touch. But the centerpiece was always the water itself, a large, deep, and often open-air plunge pool filled with shockingly cold, fresh water. This water was continuously replenished by the constant flow from the city's aqueducts, ensuring it never warmed to the ambient temperature. The physiological purpose of this icy plunge was deeply understood. After relaxing in the hot rooms, the body's pores were open and the blood vessels dilated. The sudden immersion in cold water caused an immediate and invigorating reaction. The vessels constricted, sending a jolt through the system, closing the pores and heightening the senses. This process, known as thermogenesis, forces the body to generate heat, resulting in a surge of energy and a feeling of intense, tingling alertness that followed the initial shock. For a Roman, this was the definition of feeling truly clean and revitalized. It was the ultimate remedy for the lethargy brought on by a sweltering day. Yet the role of the frigidarium extended far beyond the individual and the physiological. It was one of the most vibrant social hubs in Roman daily life. Imagine the scene: the echoing hall filled with the sounds of splashing water, lively conversation and laughter. Citizens from all walks of life, senators, soldiers, merchants, and artisans, would gather here, not in a hurried dash to get clean, but to linger and socialize. They would stand waist deep in the bracing water or recline on the cool marble benches lining the pool's edge, discussing politics, business, or the latest gossip, all while their bodies enjoyed the sustained cooling effect of the environment. It was a public, communal air conditioning unit on a massive scale. The combination of the cold water, the refrigerating marble surfaces, and the high, breezy ceilings made the frigidarium the coolest public space in the city, a sought-after refuge where one could escape the oppressive outdoor heat for hours on end. It perfectly encapsulated the Roman philosophy of salus per aquam, health through water, transforming a simple act of cooling down into a celebrated social ritual. But none of this aquatic luxury, not the splashing courtyard fountains, the serene reflecting pools, or the magnificent cold plunge of the public frigidarium, would have been possible without the true unsung hero of Roman climate control, the aqueduct. These soaring arch structures are often remembered as simple conduits for drinking water, but that view drastically undersells their role. They were in fact the very arteries of coolness, a monumental public utility that pumped the lifeblood of comfort through the heart of the empire, enabling every single water-based cooling method we've discussed. Think of Rome not as a simple city, but as a living organism. In the stifling summer heat, it would thirst and overheat. The aqueducts were the circulatory system designed to prevent that. They were gravity-fed masterpieces of engineering, channeling fresh, cold water from pristine mountain springs dozens of miles away, all the way into the densest urban centers. This was no small feat. It required a precise, constant downward slope over the entire length of the channel, often achieved by tunneling through hills and building those iconic arcades across valleys to maintain the perfect grade. The water that arrived in the city wasn't tepid or warm. It was the same cool temperature it had been at its source, having traveled underground or in shielded conduits protected from the sun's heating rays. This constant pressurized flow was then distributed through a complex network of lead and terracotta pipes to every corner of public and private life. It fed the great nymphaea, those monumental public fountains that served as both spectacular cooling displays and social hubs. It supplied the massive volumes needed for the entire sequence of rooms in the public baths, ensuring the frigidarium plunge pool remained perpetually and shockingly cold. On a smaller scale, this municipal water supply could be granted to private residences for a fee, allowing wealthy homeowners to install their own piped water systems. This directly enabled the courtyard fountains and impluvium pools that were the centerpieces of domestic climate control. The aqueduct's power lay in its relentless, uninterrupted flow. It wasn't a bucket of water to be used once, it was a continuous cycle. Water would jet into a fountain or basin where it performed its cooling magic through evaporation and sound, before being drained away and often reused, perhaps to flush the city's sewers or to supply a downstream industrial operation. This meant the cooling effects were also continuous. A Roman fountain never ran dry, it never stagnated. It was a permanent, self-renewing source of refreshment, and it was this constancy, guaranteed by the aqueduct, that transformed water from a scarce resource into a tool for everyday luxury and environmental mastery. The aqueducts elevated water from mere sustenance to an active, dynamic agent of coolness, making the sweltering climate of the Mediterranean not just livable, but truly enjoyable for millions. While the home and the baths provided private and social relief, the intense heat of the Roman day did not pause for commerce or government. The heart of public life, the Forum, throbbed with activity regardless of the season, demanding architectural solutions that could provide comfort not for a single family, but for hundreds of citizens conducting business, settling legal disputes, and engaging in politics simultaneously. The answer to this monumental challenge was found in the brilliant design of the basilica, a building type so effective that its basic form would be adopted for centuries to come, most notably by Christian churches. These were not places of worship for the Romans, but grand public halls and courthouses, and their architecture was a masterclass in crowd-scale climate control. The genius of the basilica lay in its cross-section. Unlike a typical rectangular hall, it was designed with a central nave, a wide open space flanked by colonnades that supported a second-story gallery. But the most critical feature was the roof over this central nave, which was significantly higher than the roofs over the side aisles. This height difference was not just for grandeur, it was a highly functional ventilation system. The high walls of the nave were punctuated with a series of tall, clear-story windows placed just below the ceiling. These windows were the building's exhaust vents. As the body heat from a dense crowd and the warm Mediterranean sun heated the air inside, that hot air would naturally rise. The high ceiling created a vast reservoir for this accumulating warm air to occupy, keeping it far above the heads of the people below. The clear-story windows then allowed this buoyant, stale air to flow out of the building, creating a continuous suction that pulled cooler, fresher air in through the large open arches and doorways at ground level. This constant passive exchange prevented the interior from becoming a stifling, oxygen-depleted sauna, even when packed with a bustling throng. This was combined with the tremendous thermal mass of its construction. Basilicas, like all major Roman public works, were built with thick walls of brick-faced concrete and often paved with massive stone slabs. These materials absorbed the daytime heat, preventing it from radiating inward immediately, and thus the interior temperature remained remarkably stable and manageable throughout the busiest hours of the day. Stepping from the sun-baked pavement of the Forum into the shaded, lofty expanse of the basilica would have been a transformative experience, a move from a punishing environment into a cool, dignified, and breathable space where one could think clearly and conduct business in comfort. It was a powerful demonstration of civic architecture in service of public well-being, proving that comfort and functionality could be achieved on a grand scale. Of all the grand public cooling systems the Romans engineered, perhaps the most visually spectacular and logistically audacious was the colossal canvas canopy that could crown the Flavian amphitheater, better known to the world as the Colosseum. This was the velarium, and it was far more than a simple sunshade. It was a masterpiece of tinsel architecture and specialized manpower, a temporary roof engineered to protect an audience of up to 50,000 people from the relentless Italian sun. The scale of the undertaking was staggering. The amphitheater's oval rim stretches over 1,800 feet in circumference, and covering such a vast opening required a canopy of truly monumental proportions, crafted from enormous strips of linen or heavy canvas sewn together. The real genius, however, lay not in the fabric itself, but in its sophisticated support and deployment system. A forest of wooden masts was installed atop the uppermost level of the building's facade. From these masts, a complex web of ropes radiated inward, much like the spokes of a wheel, all converging toward a central compression ring that held the entire assembly in perfect tension. This intricate network had to be precisely calculated to distribute the enormous weight of the heavy, rain-soaked fabric and to withstand sudden gusts of wind without tearing. It was a design straight out of a shipyard, and that is exactly where its operators came from. The Roman Navy didn't just lend its technology, it lent its most skilled personnel. A special unit of sailors from the naval fleet stationed at Cap Misenum was permanently assigned to the Colosseum for this very purpose. These men were the only ones with the unique expertise in handling heavy canvas sails, the knot-tying skills, and the understanding of pulley systems needed to manage this enormous structure. Working in coordinated teams from the capstans, they could unfurl or retract the massive awning with an efficiency that would put many modern stage crews to shame. Their role was so vital that they were even barracked in a nearby complex in Rome, a testament to their importance in ensuring public comfort and spectacle. But the velarium's purpose was brilliantly nuanced. It wasn't designed to create a sealed, dark environment that would trap heat and stale air underneath. Instead, it was engineered to be permeable. The fabric was likely set at a slight angle and the central ring was left open, creating a giant, sophisticated ventilation system. This design allowed the hot air generated by the massive crowd to rise naturally and escape through the central oculus, while the angled canopy still blocked the direct, scorching rays of the sun. The result was a vast area of dappled, diffused light and gentle shade, a comfortable, open-air environment that could be 10 to 15 degrees cooler than the fully exposed stone seating. For the spectators engrossed in a day-long event, this engineering marvel was the difference between comfortable enjoyment and unbearable misery, a breathtaking example of how far the Romans would go to master their environment for public benefit. Yet for the most elite and powerful citizens of Rome, even the cooling embrace of a frigidarium or a shaded pergola was not the ultimate expression of luxury. They pushed the boundaries of comfort and technology to an almost unimaginable extreme, mastering the impossible feat of bringing winter's chill to the heart of a summer landscape. This was the final frontier of Roman cooling, an extravagant and logistically staggering practice reserved for the ultra-wealthy, the importation of snow and ice from the highest peaks of the Apennine Mountains. Long before the invention of mechanical refrigeration, the Roman elite devised a system that would seem fantastical, if not for the historical evidence. Specialized teams of slaves and laborers, known as nymphaea or snowmen, would undertake perilous expeditions up into the frigid, snow-capped mountains during the winter months. Their mission was to cut and quarry massive blocks of compacted snow and ice, a valuable commodity that would become more precious than many spices as the seasons turned. This material couldn't simply be tossed onto a cart. It required careful handling and immediate insulation to survive the journey back to the city. The snow was tightly packed into straw or sawdust within double-walled containers, creating a primitive but effective form of thermal insulation that slowed the melting process just enough. Upon its arrival in Rome, this frozen treasure wasn't for immediate use. It was destined for long-term storage in specially designed underground vaults known as glaciaria or ice houses. These were not simple holes in the ground, but sophisticated, purpose-built structures. Deep pits were dug and lined with thick, insulating materials like straw or cork, and then often housed within a small roofed building with massively thick walls to provide further protection from the external heat. The snow and ice were packed in alternating layers with more insulating straw, creating a giant, subterranean thermos that could preserve its contents for months, often well into the peak of the summer heat. The use of this precious resource was the height of decadence. It was not for cooling rooms, but for the most personal of luxuries, chilling food and drink. At the lavish banquets of a wealthy patrician, guests might be served wine or fruit juices that had been deliciously cooled with chunks of mountain ice, a sensation so rare and delightful it was mentioned with awe by writers of the time. There is even evidence to suggest they created primitive forms of sorbet or sweetened ice desserts by mixing fruit pulps and honeys with snow, a direct precursor to the Italian grattacheca or even ice cream. This practice was more than just a way to beat the heat. It was a powerful status symbol, a dramatic and undeniable display of one's wealth and influence. It demonstrated a command over nature itself, an ability to summon the essence of winter to one's dining couch in the middle of August, proving that for the ancient Roman elite, no comfort was beyond reach if you had the resources and the ingenuity to acquire it. And of course, the pinnacle of this culinary coolness was reserved for the emperor and his inner circle, who could afford the ultimate luxury we discussed earlier, actual ice harvested from the mountains and stored in those subterranean ice houses. This wasn't just for show, it transformed the dining experience. Imagine being served a goblet of fine Falernian wine, not just watered down, but genuinely chilled with a piece of mountain frost, the condensation beating on the silver cup. There are even accounts of early frozen desserts, fruit pulps, honey, and even wine mixed with snow to create a primitive granular sorbet. This was more than refreshment. It was a breathtaking display of power over nature itself, a definitive statement that even the seasons bowed to the might of Rome. Their entire approach to food, from the humblest soldier's lunch to the most extravagant patrician feast, was a carefully considered strategy in the daily battle against the heat, proving that comfort could be found not just in architecture, but on the very plate before them. As the sun dipped below the horizon and the stone streets began to relinquish their stored heat, a remarkable transformation swept across the Roman world. The rhythm of daily life did not slow with the fading light. Instead, it found a new and vibrant pulse in the cool embrace of the night. For the Romans, the evening was not a time to retreat indoors and end the day, but rather an opportunity to reclaim the city from the oppressive sun, shifting a significant portion of their social and commercial activity into the more temperate nocturnal hours. This was the Roman night shift, a sophisticated adaptation that turned the darkness into a time of commerce, connection, and unparalleled culinary indulgence. The centerpiece of this nocturnal culture was the cena, the main meal of the day. For the wealthy, this was not a quick bite to eat, but the primary social event, an elaborate ritual that could stretch for 4, 5, or even more hours. These dinners were held in a special room called the triclinium, where guests would recline on couches arranged around a central serving table. The practice of reclining was itself a signal of leisure and status, a world away from our modern habit of rushing through a meal. The entire experience was designed for prolonged enjoyment and conversation, a multi-course journey through exotic dishes, fine wines, and intellectual discourse. The heat of the day had passed, and the cool night air, drifting in through open courtyards, made this lengthy ritual not just possible, but perfectly pleasant. Lamps fueled by olive oil cast a warm, flickering glow, illuminating animated faces and creating an intimate atmosphere where business deals were solidified, political alliances were forged, and poetry was recited long into the night. But this nightlife was not confined to the private villas of the elite. The common citizen also partook in the evening's offerings. Cookshops in Thermopylae, the ancient Roman equivalent of fast food counters, would remain open late, their large terracotta jars called dolia still filled with warm stews, grilled meats, and cheap wine for those returning from work or seeking a quick, affordable meal. The phenomenon of night markets is also well documented. Certain trades, particularly those involving perishable goods like fish or flowers, found it advantageous to operate in the cooler night air to prevent spoilage. The clatter of carts delivering goods to shops would echo through the streets in the pre-dawn hours, ensuring markets were fully stocked by sunrise. This created a bustling, layered economy that operated on a 24-hour cycle, with different sectors humming with activity depending on the temperature and the hour. The city itself facilitated this after-dark lifestyle with a surprising level of infrastructure. While the narrow alleys could be perilously dark, major thoroughfares were illuminated by public oil lamps placed in niches or on poles, and the facades of shops and taverns were often brightly lit from within, spilling light onto the sidewalks and creating pockets of safety and visibility. Wealthy homeowners leaving a dinner party would be accompanied by slaves carrying torches or lanterns, not only lighting their path, but also serving as a mobile security detail. The presence of the vigiles, Rome's combined firefighting and police force, who patrolled the streets throughout the night, provided a further sense of order. This active nightlife required a different day structure. The first few hours after sunrise were for business and legal matters, while the afternoon was reserved for a rest period, the meridiatio, allowing everyone to sleep through the worst of the heat and gather the energy for the long, cool, social evening to come. It was a complete recalibration of the daily cycle, a brilliant societal adaptation that turned the challenge of the climate into an opportunity for richer, more engaged living under the stars. For the wealthiest citizens of Rome, the ultimate solution to the summer heat wasn't just a cool room within the city. It was a complete and total escape from the urban furnace altogether. When the stagnant air, the relentless noise, and the radiating heat from miles of stone pavement made the capital unbearable, the elite would simply leave. Their destination was the Villa Rustica, a sprawling country estate that represented the pinnacle of seasonal luxury and environmental savvy. This wasn't a mere farmhouse, it was a self-sufficient paradise, a carefully curated retreat designed to provide respite not just from work, but from the very climate of the city. The choice of location was the first and most critical piece of this strategy. These villas were not built on the flat, hot plains surrounding Rome, but were deliberately sought out in the cool, elevated regions of the surrounding countryside, particularly in the foothills of the Apennine Mountains or along the dramatic cliffs of the coastlines, like those at Pompeii or in Latium. Elevation itself was a powerful natural air conditioner. For every 300 feet of altitude gained, the air temperature drops by about 1 degree Fahrenheit. A villa built 1,000 feet above the city could enjoy air that was naturally 3 or 4 degrees cooler before any other architectural features were even considered. But the benefits went far beyond simple altitude. These hilltop and coastal locations were also perfectly positioned to capture the relentless and refreshing breezes that sweep across the Italian peninsula. A villa owner would have their main living quarters and porticos oriented to face the northwest, directly welcoming the cool chorus wind we discussed earlier. This wasn't a gentle puff of air. At that height, it was a constant, vigorous wind that would flow unimpeded through the colonnaded walkways and vast open-air reception rooms of the villa, scouring away any hint of humidity or stagnation. The design of these country homes took the principles of urban domestic architecture and amplified them on a grand, almost theatrical scale. The central peristyle garden was not a modest courtyard but an expansive, park-like landscape, often featuring ornate fountains, long reflecting pools, and a rich variety of shade trees that created a deep, cool canopy. Dining took on a new dimension here. Instead of an interior triclinium, meals were often served in a specialized outdoor room called a dieta. This was a paved roof platform with its walls replaced by a panoramic series of curtains that could be raised or lowered to control the sun and breeze. Here, reclining on their couches, the elite could enjoy a multi-course feast while gazing out at a breathtaking vista of their own vineyards or the sparkling Mediterranean Sea, all while being cooled by the elevated winds. It was the perfect synthesis of luxury, landscape, and climate control, a world away from the stifling, crowded streets they had left behind. This seasonal migration was the ultimate expression of Roman comfort, proving that sometimes the most effective way to control your environment is simply to find a better one. This deep understanding of the wind wasn't just a general principle. Roman architects and urban planners possessed a remarkably sophisticated knowledge of specific, named winds, each with its own personality and climatic effect. They didn't just design for a breeze, they designed for the breeze, meticulously orienting entire cities and individual structures to welcome the beneficial winds and block the oppressive ones. Two of the most critical characters in this meteorological drama were the hot, dusty Sirocco blowing from the southeast and the cool, dry Mistral rushing down from the northwest. The Roman approach to these winds was a masterclass in environmental pragmatism, turning the very air into a tool for urban comfort. The Sirocco, known to the Romans as a fur ventus or the African wind, was a force to be mitigated. This wind originates over the scorching deserts of North Africa, gathering heat and fine Saharan dust as it travels across the Mediterranean Sea. By the time it reached the Italian peninsula, it was a blast of humid, gritty, and enervating heat that could make a summer day utterly miserable. Roman builders treated this wind as an adversary. They understood its direction and learned to build defenses against it. The external walls on the southeastern side of the building were often made especially thick and featured very few, if any, windows or openings. This created a formidable thermal and physical barrier. In city planning, the orientation of entire residential districts could be influenced by the path of the Sirocco, with the aim of using larger public structures or natural topography as a shield for the more vulnerable living areas. The goal was never to completely seal themselves in, but to strategically deflect this undesirable airflow, preventing its stagnant heat and dust from penetrating the heart of their homes and cities. In direct opposition was the welcomed relief of the northwestern wind, which the Romans would have known as chorus or chorus, a precursor to the mistral that famously funnels through the Rhone Valley in France. This was the wind they actively courted. Cool, dry, and vigorous, it was seen as a cleansing force, capable of sweeping away humidity and the stagnant air of a hot afternoon. The entire art of architectural orientation was in many ways an elaborate courtship ritual with this very wind. When surveying a new building site, the librators, the Roman land surveyors, would carefully note the prevailing wind patterns. The ideal orientation for a domus or a public building like a basilica would have its main entrance and largest openings facing northwest, directly inviting this cool chorus wind to enter and flow through the interior spaces. This wasn't a passive hope, it was an engineered invitation. The alignment of streets in new colonial towns was often planned on a grid, with the main thoroughfares deliberately set parallel to the path of these cooling winds, effectively turning the city itself into a series of wind channels that could flush out heat and freshen the air for all its citizens, not just the wealthy few. This nuanced understanding transformed Roman architecture from a static collection of buildings into a dynamic interface with the environment. A Roman architect was as much a meteorologist as a designer, reading the winds like a map and drawing up plans that harnessed their power. By studying the personalities of the Sirocco and the Mistral, they could choreograph the movement of air through a space, creating a natural ventilation system that was both free and infinitely sustainable. This profound respect for the natural world and the cleverness to work with it rather than against it ensured that a cool breeze was never left to chance, but was instead built right into the very foundation of their civilization. Yet behind every ingenious architectural system, every flowing fountain, and every chilled glass of wine, there was an unseen and often unacknowledged workforce that powered this entire economy of comfort. The human body itself was one of the most essential tools in the Roman arsenal against the heat, but it was rarely the body of the person enjoying the cool relief. For the wealthy elite, the most immediate and personal form of climate control was not a building or a gadget, but a person, a slave tasked with the sole purpose of mitigating their master's discomfort. This human element was the vital and tragically overlooked final component in the Roman pursuit of the perfect temperature. Within the private confines of the domus, a specific class of household slave, often a young boy or girl for their perceived agility and quiet presence, might be assigned the role of flabellifer, the fan bearer. Their tool was the flabellum, a large, rigid fan typically crafted from peacock feathers, linen stretched over a frame, or even palm fronds. Their duty was monotonous yet absolutely essential: to stand attentively beside the reclining master or mistress during the afternoon rest or the lengthy evening scena, and create a continuous, gentle breeze with a steady, rhythmic motion of the fan. This was not merely a symbolic gesture of luxury. The constant airflow they generated significantly accelerated the evaporation of sweat on the skin, providing a genuine and immediate cooling sensation that no stationary architecture could match. In a crowded dining room, despite the best cross ventilation, body heat could still build up. The flabellifer was a mobile, targeted solution to this problem, a living, breathing personal cooling unit whose silent labor made the difference between comfort and perspiration. Their responsibilities often extended beyond just fanning. Another common practice involved another slave, perhaps an aquarius or water carrier, lightly sprinkling water on the paved floors of the courtyard or the mosaic tiles of the reception rooms. As this fine mist evaporated, it would draw heat from the immediate environment, providing a quick and effective way to drop the temperature in a specific area by several degrees before a gathering or meal. These slaves were the operators of the home's climate systems. They were the ones who understood the intricate choreography of opening and closing specific shutters to catch an afternoon breeze, who managed the flow of water into the impluvium basin to maximize its cooling evaporation, and who ensured the delicate plants in the peristyle garden were watered to promote their transpiration. Their intimate daily experience granted them a practical understanding of the home's microclimates that far exceeded the theoretical knowledge of the architect who designed it. The operation of large-scale public cooling also rested on their shoulders. The teams of sailors from Misenum who managed the Colosseum's colossal velarium were highly skilled, but they almost certainly commanded a crew of slaves to man the capstans and haul the heavy ropes. In the country villas, it was enslaved nymphaea who undertook the dangerous winter expeditions into the Apennines to quarry the snow and ice, risking their lives to harvest a luxury their masters would enjoy months later. They then maintained the underground glaciaria, knowing precisely how to pack the straw insulation to ensure the ice survived the long summer. This reliance on human labor for comfort highlights a profound paradox of Roman civilization. Their architectural and engineering genius was breathtaking, but their highest standard of living was ultimately made possible by the exploitation of countless individuals whose own comfort was likely the last priority. Their silent, constant effort was the indispensable force that turned brilliant Roman ideas into daily Roman reality. Beyond the strategic placement of walls and the harnessing of breezes, the Romans mastered a more subtle art of climate control, one that played with light itself. They possessed an intuitive understanding that color and reflectivity were not merely decorative choices, but powerful tools for managing solar energy. In a world without electric lighting, the goal was to achieve a delicate balance, inviting enough sunlight to illuminate their spaces without inviting the heat that came with it. Their solution was a sophisticated palette of materials and finishes designed to literally bounce the sun's thermal energy away, creating interiors that felt both brilliantly bright and remarkably cool. The most straightforward application of this principle was in their choice of paint. While our popular imagination often paints ancient Rome in deep reds and earthy terracottas, the exterior walls of buildings, especially those facing the full force of the sun, were frequently finished with light-colored washes. They used lime-based whitewash and pale ochres to create bright, reflective surfaces. A white wall behaves very differently from a dark one under the intense Mediterranean sun. Instead of absorbing the sun's rays and converting that energy into heat, a light-colored surface reflects a significant portion of the solar radiation back into the atmosphere. This simple choice had a dramatic cumulative effect across the cityscape, reducing the ambient temperature in streets and courtyards, and, most importantly, preventing the walls from heating up and radiating that warmth into the interior living spaces. Walking down a street of whitewashed buildings would have felt noticeably less oppressive than a canyon of dark stone, but for the wealthy, this strategy reached its absolute zenith with the use of polished marble. This was not just a statement of opulence, it was the pinnacle of Roman reflective technology. Marble, particularly in its pure white forms like Carrara or the brilliant white marbles from Greece and Anatolia, was quarried, cut into thin slabs, and painstakingly polished to a high gloss finish. This process unlocked the stone's full potential as a mirror for sunlight. These polished sheets were then used as a veneer, cladding the interiors of important rooms, courtyards, and most famously, the public baths. The effect was twofold. First, the marble's high albedo or reflectivity meant it rejected solar heat, helping to maintain a lower room temperature. Second, and just as importantly, it amplified the available light. Sunlight entering through a window or the compluvium would bounce off these gleaming walls and floors, scattering and diffusing to eliminate dark corners and create a soft, radiant glow that made artificial light less necessary during the day. This created a perceptual coolness as well. A bright, airy room simply feels cooler and more spacious than a dark, shadowy one, even at the same temperature. This philosophy extended to their roofing materials as well. While less glamorous than marble, the choice of roofing tile was made with climate in mind. The classic Roman roof was covered with tegulae and imbricates, flat and curved terracotta tiles respectively. These tiles were often finished with a rich red terracotta color after firing, which we associate with the region today. However, evidence suggests that many were also treated with a light-colored slip or lime wash. A light-colored roof dramatically reduces what is known as the attic effect, where heat builds up under the roof and then radiates downward into the living spaces below. By reflecting a substantial amount of solar radiation, these treated tiles kept the entire upper structure of the building cooler, which in turn made the rooms below more comfortable. Even their water features played with reflection. The still surface of a piscina or shallow pool in a garden wasn't just for storing cool water. It acted as a horizontal mirror, strategically placed to double the light and visually expand the space while contributing to a cooler microclimate. Through this deliberate use of light and reflection, the Romans demonstrated that sometimes the most effective way to change your environment is not to fight its forces, but to cleverly redirect them. Yet to truly grasp the pinnacle of Roman public cooling, we must step beyond the individual frigidarium and behold the entire system it belonged to, the immense thermae or imperial bath complex. This was far more than just a place to get clean. It was the ultimate state-subsidized climate control center, a sprawling sanctuary of thermal therapy accessible to every Roman citizen for a minuscule fee. The genius of the thermae was its architectural choreography, a carefully sequenced journey through a series of meticulously engineered environments designed to actively regulate the human body's response to heat. A visitor didn't simply choose a hot or cold pool. They embarked on a prescribed ritual of heating and cooling that was believed to be essential for both physical health and mental well-being. The experience began in the atrium, the changing room, where one would shed the dusty, sweat-soaked tunic of the city streets. From there, the standard sequence was a gradual acclimatization. The first stop was often the palestra, an open-air courtyard for exercise. Here, one would work up a sweat through wrestling, ball games, or weightlifting, preparing the body for the thermal treatments to come. Following this, the bather moved into the tepidarium, the warm room. This space was the crucial transitional chamber, gently heated to a comfortable temperature to prevent the shock of moving directly from cold to extreme heat. Its purpose was to begin the process of opening the pores and relaxing the muscles in preparation for the intense heat that followed. The climatic peak of the heat experience was the caldarium. This was the hottest room in the complex, a stunning domed hall flooded with light from large windows facing the sun. The floor and walls were hollow, creating a space beneath them called a hypocaust. In a furnace room, slaves, the fornicators, would maintain a raging fire, and the hot air and smoke from this fire would be channeled through these cavities, heating the tiles above to a high temperature. The air in the caldarium itself was often thick with steam, and a large hot water plunge pool, the solium, sat at one end. The intense dry heat from the floors and the moist heat from the pool worked together to induce a profound sweat, a process believed to purge the body of impurities and toxins. After soaking in this enveloping warmth, the bather would be scraped down with a curved metal tool called a strigil to remove the oil and sweat, a process that was both hygienic and exfoliating. Only after this thorough heating was the body deemed ready for the cooling climax. The bather would then leave the oppressive heat of the caldarium and return to the moderate tepidarium, allowing a gradual cool down before the final, exhilarating plunge. The journey culminated in the magnificent frigidarium, the grand cold hall we discussed earlier. This was the architectural and sensory opposite of the caldarium, vast, open, and filled with cold, fresh air and the shimmering light reflected off polished marble. The shock of the cold plunge pool closed the pores, tightened the skin, and sent a surge of energy through the system, leaving the bather feeling invigorated, cleansed, and perfectly thermally regulated. This entire progression from warm to hot and back to cold was a deliberate physiological reset, a sophisticated understanding of the body's response to temperature that modern spa culture still emulates today. The thermae were the ultimate expression of a society that had turned the essential human need for comfort into a magnificent, democratic, and deeply social art form. Looking back at these ancient techniques, it's not just a history lesson, it's a source of inspiration. The Roman approach to cooling wasn't just clever, it was inherently sustainable. They worked with nature, not against it, using geometry, physics, and biology to create comfort without consuming finite resources. In an era defined by climate change and soaring energy demands, their passive strategies feel more relevant than ever. Modern architects and engineers are now actively looking to the past, asking a compelling question: how can we adapt these 2,000-year-old ideas to create the green buildings of the future? The principles are just as sound today as they were then. Take cross-ventilation, for instance. The Roman understanding of wind orientation and building alignment is a fundamental lesson in bioclimatic design. Today, we can use sophisticated computational fluid dynamics to model airflow with incredible precision, but the goal remains the same: to orient a structure to capture prevailing breezes and facilitate their movement through interior spaces. This isn't about reinventing the wheel, it's about applying ancient wisdom with modern tools. We see this in the renewed popularity of courtyards and atriums in contemporary design, which act as thermal chimneys just like the Roman atrium, drawing hot air up and out while pulling cooler air from shaded areas below. The Roman mastery of thermal mass is another concept experiencing a major revival. While we may not use Roman concrete, the principle of using dense materials like stone, rammed earth, or modern high-mass concrete to absorb heat by day and release it by night is a cornerstone of passive solar design. This drastically reduces the need for mechanical air conditioning as the building itself regulates its temperature. Furthermore, the strategic use of light-colored, reflective surfaces, a tactic seen in Roman whitewashed walls and polished marble, is directly echoed in today's cool roof technologies. These specially designed reflective roofs and pavements can significantly lower urban heat island effect, reducing ambient temperatures across entire cities and directly cutting down on cooling energy demands. Perhaps the most elegant Roman innovation we can adopt is the integration of water and vegetation, the evaporative cooling from a courtyard fountain, or the transpiration from a shaded pergola are powerful, low-tech cooling methods. Modern landscape architecture is increasingly focused on this, using features like misting systems, reflective pools, and especially extensive green roofs and living walls. A green roof does exactly what a Roman pergola did. It provides insulation, absorbs solar radiation, and cools the surrounding air through evaporation, all while reducing stormwater runoff and supporting biodiversity. It's a multifaceted solution that improves a building's performance and the well-being of its occupants, just as the Roman peristylium did. The real takeaway from Roman design is a philosophical one. It teaches us to think of a building not as a sealed box to be artificially climate-controlled, but as a living, breathing organism that interacts dynamically with its environment. Their methods required foresight, orienting a building correctly during the initial planning stages, choosing the right materials, and incorporating landscaping as an essential component of the design, not an afterthought. This holistic view is the essence of modern sustainable architecture. By blending their time-tested passive strategies with our advanced materials and smart technology, we can create buildings that are not only more energy efficient and cost-effective to operate, but also healthier and more pleasant to inhabit. The Roman blueprint for cool comfort has been available for millennia. It's now our responsibility to build upon it. From the architectural genius of the atrium and the cryptoporticus to the social innovations of the nocturnal city and the public baths, the Romans didn't just endure the summer heat, they engineered a complete culture of coolness. Their approach was a symphony of strategies, each playing its part in a grand holistic design. They manipulated air with cross-ventilation and towering basilica windows, mastered water with aqueduct-powered fountains and frigidarium plunges, and commanded shade with colossal velarium awnings and living pergolas. They even harnessed the very earth itself, using subterranean thermal mass and imported mountain snow to defy the seasons. What's truly breathtaking is that they achieved all of this without a single watt of electricity, relying instead on a profound and observant partnership with the natural world. Their creativity was born from a deep understanding of physics, materials, and human physiology, turning the fundamental challenges of their environment into opportunities for elegance, comfort, and social connection. It was a sustainable, intelligent, and holistic system that modern design is only now beginning to fully appreciate and emulate. So we have to ask you, after this journey through ancient ingenuity, if you could bring one of these Roman cooling techniques into your own life today, which would it be? Would it be the constant, gentle breeze of a perfectly oriented domus, the shocking refreshment of a plunge in the frigidarium, or the simple, elegant luxury of a shaded stroll through a perfumed peristyle garden? Let us know your thoughts in the comments, and if you enjoyed uncovering this historical mystery with us, be sure to subscribe so you don't miss our next adventure into the past.